Morning, everybody. So I've had some requests for some problems, and so this is first the problem from section 3.1, number 15. And the basic gist is are you looking at a function or not? And my advice to you in these problems is to solve it for y, graph it, and see if it passes the vertical line test. There are some telltale signs, so I'm going to do a couple just to give you an idea. But solving this for y, I'm going to cross multiply, so I'll have 7y minus 1 times x equals 3y plus 5. Distributing the x, I have 7xy minus x is equal to 3y plus 5. I'm going to move the 3y over and the x over, so I subtracted 3y on both sides and I added x on both sides. The reason I'm doing that is I want to be able to factor this y out, and now I have 7x minus 3. I'll divide 7x minus 3 and 7x minus 3. And so I have the equation y is equal to x plus 5 over 7x minus 3. And what happens is for every x you plug in, you're going to get one y value out. And if you check it on your graphing calculator, that'll hold true. So it's a function. That relation is a function. Number 20, you have x is equal to y cubed. Again, I'm going to solve for y, so I'm going to take the cube root on both sides. The cube root of y cubed is y. The cube root of x is just written the cube root of x. And if you graph that, you'll find that you have a function. Any x that you choose, you're going to get one y value out. And it's often the case that radicals create some issues, so I wanted to grab another one that sort of represents this. Suppose we have x squared plus y squared equals 9, and that's number 18 in the book. And I'm going to solve for y, so I take the x squared over, I subtract x squared on both sides. And so I have 9 minus x squared, and I have y squared is equal to that. So I'm going to take the square root, and I take the square root. So I'm actually imposing the square root on both sides. When I impose the square root, I have to put plus or minus. Now you'll notice if I choose a value for x, say, I don't know, 1. 9 minus 1 is the square root of 8, plus or minus the square root of 8. So you're getting two values out for one x. It's not a function. And if you graph this on your graphing calculator, what you actually have to do is you have to do y1 is equal to the positive square root of 9 minus x squared. And then you have to graph y2 is equal to negative the square root of 9 minus x squared. And then it actually graphs for you. You can't put plus or minus in, it only reads it as a function. Okay. Now, there was another question in section 3.1 about number 32. And it's telling us actually to do some form of the slope formula. It's actually a rate of change problem where it says g of x plus h minus g of x. And so it reads this way. And this is actually a calculus, g of x plus h minus g of x. It's actually a calculus formula or part of a calculus formula, to be fair. So first we need to find what g of x plus h is, and then we need to find what g of x is. So g of x plus h. Well, our function in the problem is 5 minus x squared. So we're going to take the 5, that's there, the minus, that's there, the squared, that's there, but what's going to replace the x is x plus h, so you're looking at it as x plus h, and that means x plus h times x plus h, and if you FOIL that out, you get x squared plus 2xh plus h squared. So this expression here in our slope formula will become 5, and we distribute the negative, so it's minus x squared minus 2xh minus h squared. Now, in the formula, you'll notice that there's a negation, and so we have to pass the negative through on the g of x, so it becomes minus 5 plus x squared. Well, this 5 and this 5 eliminate, and this x squared and this x squared eliminate. So you're left with negative 2xh minus h squared all over h. And we can factor an h out, and so we have h times negative 2x minus h all over h, and we can cancel the h's, and we're left with a negative 2x minus h. Okay, hopefully that's helpful.